Hello, this is Mr. Anderson for Kellogg Community College, and today we're going to be going through our Chapter 8 test review. There's a couple things I want to show you in here that you might be able to do more than just use the quadratic formula. Sometimes factoring is going to be the better or easier way to do it, but the quadratic formula will always work. Now, what's going to be interesting about this test is sometimes you're going to have to work a little bit to get the quadratic formula. Not all of the problems will be set up in terms of ABC, where it's something ax squared plus bx plus c equals 0. Like in this case, the a is 3, because a is the coefficient in front of the x squared. B is 0. There is no x, or 0x is not written in the simplified form, and the c is negative 75. So what we're going to do is we are going to now load this into the quadratic formula. Negative b plus or minus the square root of rb squared minus 4 times a times c. All divided by 2 times a. Okay, so now what we're going to do is we're going to simplify this. 0 squared minus 4 times 3 times negative 75 gives you an answer of 900. So it's 0 plus or minus the square root of 900 over 6. Now, 0 is going to make things a little easier because, 0 is just 0. But the square root of 900 is a perfect root. You can check that on your calculator because what you then get is 0 plus or minus 30 divided by 6, which is another way of saying plus or minus 30 divided by 6. So that gives you a nice answer here of plus or minus 5, because 30 divided by 6 is 5. So your answers are negative 5 and 5. Now, again, that's one way you could have done the problem. Another way you could have done it is use factoring and use your Chapter 5 rules for solving for x. You can factor out a 3 in this problem. You get x squared minus 25 equals 0. Then you can notice that this is a difference of squares. And using that factoring rule from Chapter 5, this becomes 3 times the quantity of x minus 5x plus 5 equals 0. Sometimes professors or teachers will tell you to just ignore the 3. Another situation, if you're really bothered by it, you can divide both sides by 3 when solving for x, and therefore you just have to concern yourself with the x minus 5 and the x plus 5. So when you solve an equation like this, you'll notice that x minus 5 or x plus 5 have to be 0 to make this statement true, or both of them can be 0. So what we do is then take each binomial and set them equal to 0, and then solve for x. So this is going to be x as I add 5 to both sides, x is equal to 5, and as I subtract 5 from both sides, x is equal to negative 5. So it gives me the same answer set, and I'm just writing these out like this, but set notation would look like this. This would be the set of these two answers to fulfill the problem. And it just depends on what your professor or teacher is asking you to do when you have to write your answer in the end form. So we got 3 more problems here, each with varying degrees of difficulty. So in problem number 2, there we go. In problem number 2, it's almost set up in the correct form. It's just that we have to bring the 10 over to the left-hand side to meet up with my a and my b. So we subtract 10 from both sides, and then what we have is x squared minus 3x minus 10 equals 0. You know you're doing it right if you get the equation set equal to 0. Alright, so what I'm going to do is use quadratic formula. A equals 1, b equals negative 3, c equals negative 10. So what we have here is 3 plus or minus, that's the negative b, plus or minus the b squared minus 4 times a times c. All divided by 2a, 2 times 1. So what we have here is 3 plus or minus, and if you compute that into your calculator, what you get is the square root of 49, all divided by 2. And what I like to do here is I like to kind of split the wheels of the truck up a little bit, or split the 2 up. So what I have is 3 halves, and I do this because sometimes you're able to simplify the first and second fraction. The square root of 49 over 2 is another way of saying 7 halves. So I'm going to split this into two problems because it's a plus minus. So I got 3 halves plus 7 halves, and I'm going to have 3 halves minus 7 halves. Now 3 halves plus 7 halves is 10 halves, so the answer is 5. Now down here, 3 halves minus 7 halves is negative 4 halves, so the answer is negative 2. So your answer is negative 2 and 5. Now another way to do this problem from this step is to factor it. And at this moment, I think you're possibly pondering like, wow, these problems have been really easy to factor so far. I promise you on the test, I will kind of ratchet up the difficulty on the factoring here, so you'll be more inclined to use quadratic formula, or you'll have a problem that looks like it's factorable, but it's just not. But in case you did see that it was factorable, I'll show you how nice this will be without quadratic formula. The two numbers that multiply to make negative 10 and add to make negative 3 are negative 5 and positive 2. Since we have two binomials that are multiplied together to make 0, it means one of them or both of them have to be 0. So x minus 5 is 0. We take the first binomial, set it equal to 0. X plus 2 is equal to 0. Add 5 to both sides. X is equal to 5. Subtract 2 from both sides. X is equal to negative 2. So again, same answer set. And I just wrote these out, but the set form would be, this finite set containing these two elements of negative 2 and 5. All right, halfway done with this page here. Let's go back to problem number 3. Problem number 3 needs a lot of manipulation to actually make it look like a quadratic formula. Your first step here is to distribute. So this is going to be 5x squared minus 5x. Careful in this distribution right here. This is going to be negative 4x squared, negative 16x. That's important because you're distributing the negative 4, which makes both of these negative. This is equal to negative 110. Now we're going to combine like terms over here, so this gives me x squared, and the negative 5 and the negative 16 is negative 21. Just making sure I didn't make any mistakes by checking my notes. I'm going to move my 110 over here. And I'm going to do that by adding it. Oh, shoot. So again, adding the 110 to both sides. Puts it right there. Sorry, that 1 looks a little weird. Okay, let's use quadratic formula. A is equal to 1, B is equal to negative 21, C is equal to 110. All right, so with that in mind, here we go. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Well, if we compute the discriminant inside the radical there, or the cargo inside the trailer truck there, what we get is we get a 1. That's it, just 1, square root of 1. And down below we have a 2. So what this is going to make, and I'm going to kind of split the wheels up here just because when I'm getting exact values, that's kind of nice. Now the square root of 1 is just 1. So 1/2, and I'm going to split this up to here and here. So 21 halves plus 1/2 is 22 halves, which is 11. And 21 halves minus 1/2 is going to be 20 halves, which is 10. So your answer is 10 and 11. Now again, this is another problem where you might have seen at this moment when we simplified it to x squared minus 21x plus 110 equals 0. What you might have seen is that, oh my goodness, this is factorable, because the two numbers that multiply to make 110 and add to make negative 21 is negative 11 and negative 10. Then, following the same process of setting the binomial equal to 0, looks like I got the order, I just flipped the order for no good reason, to be honest. X is equal to 10, and x is equal to 11, because we added 10 to both sides. And we added 11 to both sides. And again, I know you're about 10 minutes into the video. I really strongly want to suggest that you practice all the homework problems if you want to see something more difficult. In fact, your answers will have imaginary numbers and radicals that can't be solved or simplified any further, and we're about to see that in the next example here for to wrap up the video for the first page of our 6-page practice test. Okay, so here we have x squared plus 4x plus 5. All right, so this problem is not factorable. I know a lot of you might think that, but this would have to be a subtracting 5 or a subtraction for it to be factorable, because then you could use positive 5 and negative 1. But the way it sits right here, this is not factorable, so no chance of that happening. So we're going to use quadratic formula, so A, B, C. All positive numbers, so negative b plus or minus the square root of b squared minus 4 times 1 times 5. All over 2 times a. Now, you'll see that I use parentheses every time I substitute. That's just good practice. It's good math practice to use parentheses when you substitute. In the case that you have a negative sign that gets a little confusing, the parentheses kind of sort it out. Now, if you do the inner guts of this problem here, where you have 16 minus 25, you get the square root of a negative number, which in this case is negative 4. So, 16 minus 20. I said minus 25. I mean 16 minus 20. This gives you a negative 4 inside of the radical. And now you get to see why I like to kind of split up the wheels here. So I'm going to just kind of take things a little slowly here, because I can write this as negative 4 over 2 plus or minus the square root of negative 4 over 2. And what I'm going to do now is really focus on this square root here. What we learned back in chapter 7, we can take our negative square root and break it into the product. This is the product rule of square roots. We can make it the product of 4 times negative 1. And the square root of 4 is 2, and negative 1 under the square root is I. You'll notice that the square root goes away. There is no square root of negative 1. That's not going to be happening in this level of math, nor do I think it's applicable. So let's go and take a look at our problem here. I now have negative 4 over 2 plus or minus 2i over 2. And I'm just going to tighten this up a little bit. This is negative 2 plus or minus I. And in this case, since this will not break down to make a whole number, I'm not going to be actually splitting this up into 2 problems. I know the answer key might have negative 2 plus I, comma, negative 2 minus I, but frankly, that is the same thing as this written. So again, depending on what your instructor wants, you might have this answer and this answer. It's up to you how you want to do it, or it's up to them technically. So I thank you for watching the first of the 6 pages of this review.